This meeting is being recorded.
All right, this meeting is being recorded. So anyway, welcome everybody to Solar Noon Tuesday. And what I will do is try and go through the news of the week here. And as always, if you have any questions as we go through this, just feel free to interrupt. The news this week, I really got a sense of it when I was looking through of it. It's kind of a sense that solar has come of age because all sorts of agencies at the federal level and at the state level are jumping in to see how they can sort of impose their own unique brand of regulation on the industry. So I think that's a fair indication that a lot of folks who haven't traditionally thought of solar as a legitimate thing after the Inflation Reduction Act, they're saying this is a real thing here. So the first one was FEMA. FEMA has decided that they're going to petition for the 2024 International Building Code to increase the classification requirements for ground-mounted solar from a Category 1 to a Category 4. So this could be a big deal, especially at the utility scale. And so let's look a little bit closer what Category 1, what Category 4 is. Category 1 is essentially the lowest classification. It's temporary storage facilities, agricultural storage facilities, essentially things that do not have any impact to human habitation and also are not vital systems. Now, this all deals with natural disasters, you know, hurricanes, earthquakes, tornadoes.
Jay, are you sharing your screen?
I should be. Let's see what's going on here. Am I just talking?
Be me, but you're a little block like everybody else.
All right, I'm a little block with everybody. Oh, you know what? I probably did. No, I put it to speaker.
It might just be me. I don't know.
No, I'm seeing you as a full. I had this problem before. Yeah, it's still. Let's switch back to this camera, and then I'll switch back. I had been so good to get this all set up ahead of time. Can you see it now?
I can see it, but it's still a little blocked. Is it big screen for anybody else?
No, it's still a small screen.
I got a big screen.
Okay, did it just come through as a big screen? Maybe what you need to do is on your view, kick it over to speaker instead of gallery in your Zoom view.
I think I am.
Okay. Let's take a vote. Is everybody seeing me as right now? It should just be text there.
No, we see you. It's very small.
Technology. Don't you love it? All right. Let me think. What can I do here?
Jay, I can see. Yeah, there's like a risk category and nature of occupancy. Yeah, that's on the screen, and like your head's behind it.
Picture in picture, kind of.
Okay. All right. I'm going to just assume, as I move forward, and maybe it's just an isolated thing where broadband's going to catch up there. Okay. So if I switch here, the Category 1, now it should be switching to a Category 4. Everybody, can you see that? More details? Get some feedback?
Yes, sir, I can.
All right. Okay. So Don, it's probably just Kentucky internet there.
Could be.
You guys are always slow. If you go up in the upper right-hand corner under view, you should be able to switch it from gallery to speaker.
Okay.
All right. Okay. So anyway, what they're proposing there is that the classification be changed from basically temporary storage buildings to a Category 4, which is the same as, earthquake shelters, hospitals, military defense systems. So it really is taking it from the lowest to the highest. This is their recommendation. And what SEMA, the Solar Energy Manufacturers Association, is saying, and I think it's CEA as well, is they're coming back and saying, listen, guys, this is going to add a lot of costs to the installation of these ground-mounted systems with no demonstrated reason for it. This has not been an issue. You know, we haven't seen a lot of solar fail because of natural disasters. On the other hand, my guess is what FEMA is doing is they're coming back and saying, you know, distributed energy, especially ground mounted solar, is becoming more and more vital to our infrastructure. So it should be hardened the same as any other utility infrastructure. So you can see that argument, but it's going to be a severe impact to the industry if this does in fact go through. Now, another thing that's out there in the regulatory body is the Department of Energy is saying, okay, now as we're developing this infrastructure, we should be looking at cybersecurity from the ground up. Currently, we have about 90 gigawatts of distributed solar. 3 million systems are currently installed in the United States. And they're saying over the next 3 years, that's expected to quadruple to about 12 million systems. So each one of these systems is connected through a communication device through the greater internet. And it is susceptible to hacking and other type of disruptions. So we should build it in. In fact, they're calling it cyber by design, which would be, let's just factor that in. Seems like a smart approach at least, but we'll see. We'll see if anybody follows it. We always seem to be good at recovering from disasters and not preventing them. So we'll see how that works out. The Department of Treasury is coming back now along with the IRS and asking for industry input, how to implement the Inflation Reduction Act. This Inflation Reduction Act is seismic in its scope. About $270 billion of this act are going to be implemented through tax incentives. So the IRS, the Department of Treasury, they're saying, okay, we need guidance from the industry as to what constitutes a lot, or how do we answer a lot of these questions? You know, for example, what technologies are green? What technologies will be incorporated within this? What standards apply when we begin to evaluate what qualifies, what doesn't qualify? If you've got an existing system and you substantially retrofit it, is that now to be considered a new system? If so, to what extent? So there's a lot of those kind of things. There's other incentive enhancements, the investment tax enhancements. We've seen that they apply, many of them only apply if you've paid prevailing wage. So what the IRS is saying, okay, how do we measure that? What is required there? Is it the Davis-Bacon Act? Is it what kind of record keeping is required for us to authorize that you have indeed paid prevailing wage? How do we determine when a system is completed? You know, these things are often ongoing in nature. So what constitutes completed? If you're going to give extra credit for domestically manufactured supplies, you know, what kind of records do you have to maintain to prove that all of the components that went into this system? So it's on and on and on. There's going to be a million of these things that come forth. So they've gone out and asked for feedback. There's, you know, building enhancements. How do you maintain those records? Electric vehicle, those require domestic batteries. So how do we figure that out? Manufacturing credits. If we can buy and sell and trade these incentives, what kind of records are required? How is that handled? So a lot of questions. It's interesting. I was listening to a podcast. I think I mentioned this last week. And a lot of the people in the industry are saying, okay, we're going to look back years from now and say, there was the solar industry before the Inflation Reduction Act, and then there's the solar industry after. And so much of this is transformative, and we need to work it out. And California Public Utilities has announced that they're going to delay the announcement of their net metering 3.0 decision until after the election. A lot of internal memo or emails are stating that they've been discussing it and saying, we don't want to bring this out before the election because there's going to be political fallout, which to me kind of signals that they're going to go against the industry and basically in support of the utilities. If you recall, they did come out earlier in the year, essentially with the recommendation to gut net metering in California. There's a graphic there that talks about some of the provisions, but there was so much pushback when they announced this that they announced, nope, let's go back to the drawing board. We're going to reevaluate it, get some more public input, and then we're going to come out with our announcement in the end of September. Well, now they've come back and said, you know what, let's delay it until after the election. So that's where that is. And pretty much that's the news of the solar industry. Hopefully, Don, you guys have gotten away from the tiny screen and we're all set there. Any questions or any feedback about solar news or anything to add to that?
Yeah, Jay, just on that last point, I just got back from LA. I was listening to Mayor Garcetti, the mayor of LA, and the chairman of the California Energy Commission talk. And just to provide a little bit of like that context to your last slide, it's a kind of a growing concern, particularly in California. And we've discussed this a little bit on the call, that it's almost like the rat scurrying out of the ship, right? As energy rates from the grid get more expensive and less reliable, those that can afford to go solar, but everyone wants to have it both ways. So they want the grid to be there to tap in when they want it, but just not pay for it.
Sure.
So what's like a top of mind concern to those folks? I'm not saying it's right or wrong, just talking to you, spending some time behind enemy lines last week, just reporting back to the group here. The thought is folks who cannot afford to install solar, marginalized communities, Black and brown communities, historically economically disenfranchised groups will be the ones left paying for everyone else to go solar. So they'll watch their rates skyrocket while the people who can afford it go solar. And I think you absolutely correctly pointed out they're just not announcing anything until the election's over, and then they'll gut the industry.
Right. Yeah, I question some of the premises on that. Of course, they've been trying to deal with the low income through community solar, which is a way of making that happen. But all of the studies I've seen is the addition of solar to the grid does not increase the cost to the grid operators until you reach a certain penetration point. And that penetration point is still some distance in the future. Until you're starting to get down below that duck curve, you're usually providing power to the grid when it's needed most. So I'm not quite sure where that's a pushback from the utilities that they've used a lot, but the studies just don't prove it out that the cost is really being added to the system when somebody goes solar. Clearly, they're going to buy less power, and clearly they are using some of that infrastructure, but they're also supplementing with low cost energy during periods of peak demand. Although that said, California is a little bit of a unique animal, and they have that thing where they're paying $2 a kilowatt hour, to folks. So it may be that there's just a lot of conflicting legislation out there that makes it a mess.
Jay, is it?
That's 100% true. I think the other element of this that complicates things or muddies the water or creates like that sets the conditions for like a little bit of crony capitalism is, LA as an example has a municipal run, like owned utility. Right. So there's some, there's some kind of circular firing squad happening here as far as, who controls what and who's making money off of whom and how that works, overlaid with renewable energy goals, and then also trying to hit diversity, equity, and inclusion kind of, benchmarks, kind of access for all. So that's Yeah, I mean, I think a lot of it, unsurprisingly, I think to anyone on this call, a little bit tied in knots over there.
Sure. Yeah, Don, you had something?
I was going to ask Jay, is the marginal energy they're paying from the solar people really low cost because they're paying retail for it essentially because of the net metering?
It is
debating
low
one or the other yet.
cost. Yeah, it is low cost compared to what they have to pay if they go out on the open market during periods. I mean, retail during
You mean
peak
just during
demand.
spike? You mean during spike periods?
Yeah.
Okay.
And so it is relatively low cost. They've also, of course, have time of day pricing. So their pricing models should reflect whatever their what their true costs are. I kind of get into that mode. Like I feel like with our utility here, they should charge me what it really costs. If they have costs, for sure, I as a solar owner should pay for some of those costs. But to go from what was essentially paying me 20 cents a kilowatt hour to 3 cents doesn't, I mean, that's a huge jump.
I'm just curious, what is their, for example, I'm thinking of Germany where they paid 3 times what the going rate was.
Yeah.
I mean, what is their real cost? You've got a municipal, a co-op like me, I think.
Yeah.
And I mean, I don't know what their cost is. Is their cost 3 cents for their regular kilowatt hour, or is their cost 10?
Well,
I mean,
I fear that if I asked my co-op, they would have no idea either.
Yeah.
So,
I don't think mine would either, but yeah.
Yeah, it's interesting because again, I was listening to another podcast, and one of the things he was pointing out is the solar industry is pretty transparent in our cost structure, what the incentives are, who receives the incentives, and the like. The utility industry has for decades been pretty opaque. A lot of their things are not as transparent, and they're probably not going to be as nimble in responding to these kind of market demands and the like. And he was making the point that is a disadvantage when it comes to this kind of competition that's coming down the line. I see California at the moment as sort of a battleground between utilities interests and an industry that's getting to a large enough scale that it's starting to hurt significantly to those utilities. It's sort of the first battleground because California is an early adopter in all of this. And it feels to me, because having been involved in some of these strategy sessions back during the telecommunication transition, they don't have control. The utilities have lost some of their political power in one venue. So they move to these venues that they do have some control. Public Utilities Commission being an example. So they can't win in the legislature. They can't win at the governor's mansion. So let's play over in this field. The same thing with the FEMA regulations. Can we fight back over here instead of dealing with them over here because we can't compete on that? And so I certainly understand it as a strategy, but is it going to work? Who knows?
I was curious with the FEMA regulations. You had said they were going to class 4, but what does that mean as far as what extra work you have to do? You showed the examples of what class 4 was, but what does it actually mean as far as extra infrastructure that you have to put in place?
Yeah, apparently, I did do some research, and it essentially is bolstering the supports. They've got to be able to withstand certain seismic activities. They've got to be able to, so you're going to use more metal.
Okay.
You're going to put in deeper
Gotcha.
foundations, more weight. So it adds to all of that.
Okay.
And fair point in that particular one. The solar industry is saying, hey guys, understand your concern, but point to some sort of track record where this has been a problem. And the FEMA folks are saying, well, you know what? This is a significant utility. We just feel you should be treated like the other utilities. We require this of substations. We require this of power plants. This is a power plant. Let's put you over there. So, there's probably rational arguments on both sides, but it's something that's going to have to, be played out here.
Mhm.
I mean, obviously I'm going to have the bias in favor of the solar position. But yeah, we'll
Won't a lot of those fields be done by utilities if they're utility scale? Won't they be done by currently in place utilities, like same way they do the wind?
yeah, a certain number of them will, for sure.
Mhm.
And that may not be an issue as far as utilities are concerned, because as we talked about last week, utilities have an incentive to spend money
Yeah.
on this kind of infrastructure. They make more
Mhm.
money if it costs them more, where that can be problematic when you're competing, in an environment where the end user customer, and this does only apply to ground mounted systems. It does not apply to rooftop systems. So, but of course, most of the big systems are going to be ground mounted.
Mhm.
Hey,
Yep.
to clarify, is this just for grid scale solar? Or are we talking residential and commercial also?
That was unclear.
Okay.
My guess is commercial will probably come into play on this rating scale because they're big enough. Whether commercial or whether residential is ever looked at as far as that's probably going to be more a local ordinance kind of situation. I don't recall the categories coming into play when I've looked at design systems. They don't ask me well, no, now I'm lying about that. Yeah, they do in some of those design programs ask you the occupancy category of the building. So it may factor
For
in.
houses.
Yeah, for
Okay.
when you plug in all of your different parameters when you're designing a racking system in some of these automated systems, they'll ask you when you put in the zip code, it
I see.
automatically gives you a wind classification and a snow loading classification. That's all in their database based on your zip code. But then they'll ask you your occupancy category. And that probably will determine, how wide your spacing is for supports, what's the depth of the hole. My guess is though that even bolstering it up to a category 4 is not going to add that much cost to a residential system. When we're talking about scale, that's where it really becomes an issue, because you're not going to be going out there driving in piles, with a GPS, helical peer driver or something like that. You're going to be digging the hole. And if you go down, 36 inches instead of 28 inches, not a big deal. So, all right. So how's that for an answer where I really don't know what I'm talking about, but I gave you an answer anyway. So that's sort of story of my life. Any other questions on the news? All right, so let's jump a little.
Just real quick, I had a thing on the Defense Department is going to be transitioning to electric vehicles, it looks like. So that's, Tony, you might get a electric battle tank here in a little bit.
A nuclear Jeep. Right. Okay. All right. Well, let's talk a little bit about some of the systems here with the, I'm going to get rid of this speaker view presentation notes. It struck me as I was looking through some of this, a lot of you guys may be involved in installing the Enphase systems, and they've been pretty straightforward up to this point, but now with the IQ8s and the like, they're starting to get a little bit more complicated. And I get a lot of questions from folks saying, I'm not really sure I want to install batteries at the moment, but I would like to install the system so that it can accept batteries in the future. And so what's required there to make sure you future-proofed it to that extent? So if you haven't already installed a Enphase combiner box, this is kind of the normal process now with the Enphase system that we go through. And part of the reason for that is up here in the right-hand corner. I think I might have a zoom up here. The Envoy, which is the communication device for monitoring the system, is located there within the combiner box. It's that circuit board that's up there in the right-hand corner. And the combiner box comes with a 10 amp breaker, double pole breaker, and that's designed to power the Envoy system. So this is what you're going to get. I don't know, when I'm moving my arrow around on the screen, do you guys see it, or am I just amusing myself here? Anybody seeing my little arrow moving around there? Probably not.
No.
Okay.
no.
All right. Well, it's good. It helps me. So anyway, there with this system, there are slots for up to 4 20 amp branch circuits. So essentially what you're seeing here is like a service panel, but with spaces there for 4 additional 20 amp breakers and double pole breakers. So what that means is you could come in with, I think each string with the IQ8s, if my memory serves, is around 13 to 15, somewhere in there. So you can come in with that many different branch circuits, up to 4 of them, up to their maximum. And then there's, when you do feed in the lines, let me back up a little bit here. Down in the bottom left-hand corner is a CT, and you'll feed line 1 from your branch circuits through that. And what that's going to do is begin to monitor the production from each of those branch circuits. And then that reports back through the system, through the Envoy, so that you can do, load monitoring. You can do, you could make some adjustments to that system if you need to remotely, as we start getting into some of these remote load controls. Okay,
Excuse me a minute, is that just for one line, or is it, that's only for like 120? It doesn't look like it's for 240.
Yeah, it's gonna, they just want you to feed in the L1 from each of those. So I think that particular CT in the combiner box is just for production. So it's monitoring that, and I guess my assumption is they double it. Who knows for that? But you're right. You're only feeding in one of those lines through that CT. Then the other monitoring lines are fed from there's some circuit board type thing up there at the top, and you will connect up there and then you'll put the CTs, you'll feed those through the CTs in the service panel. So that's, again, going to give you some monitoring of your production here as you're feeding it through. It's pretty simple to hook that up, and it's all pretty self-explanatory. So the first thing you want to figure out is, where's the location of the combiner box? Where's it going to go? Then you have to pick the circuit breakers, and the circuit breakers are a little bit odd. They're not something you can go down to Home Depot and buy. I forget the brand, but I mean, you go to an electrical supply, they'll have them. Then you want to do the wire the output. And I put 20 amps here, but that's wrong. It should say 80 amps. And what I would recommend here is, regardless of how many microinverters you're hooking up to your combiner box, wire the system as if it were maxed out. So from the combiner box to the service panel, where typically you're going to be connecting in, put in wire that can handle 80 amps, because that's the maximum build out of this unit. And you don't want to have to go re-pull wire. And you're usually only going to be pulling about, 10, 15, 20 feet at most of wire between those. You're going to go from this unit, if you're doing just a standard install without the batteries, without the auto transformer, you're going to go from this combiner box to an AC disconnect, and from the AC disconnect to your service panel. So once again, in future proofing, I would run the 80 amp wire from the combiner box to the AC disconnect, and then put in an 80 amp capable or rated So probably 100 amp AC disconnect. That would be my recommendation. Even if you're only running one string and all you need is a 30 amp, stick in 100 amp so you don't have to switch out the box later if you do decide to expand it. The cost difference is not going to be that much. And then you're going to run the 80 amp wire from that disconnect to the breaker box. And obviously remember, if you're putting in a fused AC disconnect, put a fuse in that's rated to the ampacity, the next available commercial fuse above whatever the amps you're actually running, not 80 amps. You know, if you're only running one string and you've got 20 amps, then you want to put in a 20 amp fuse in that disconnect. Same thing, your breaker at your service panel will be 20 amp. But you might want to make sure that you can go all the way to 80 amps should you expand in your service panel, which might be a bit problematic because you should remember that there's the 120% rule when you're hooking up on a load side connection. So you cannot exceed more than 120% of the rated bus bar rating of that service panel. So for example, if you've got a 100 amp panel with 100 amp service coming in from the utility, you can't put more than a 20 amp breaker coming from your solar array. If it's a 200 amp panel with 200 amp service, you can go 40. So in this case, you would either have to go with like a 200 amp panel with 100 amp service, then you've got plenty for 80 amps coming in from your solar. Or they do make, of course, service panels that are more than 200 amps. So just make sure you meet that criteria. You want to hook up your production sensors. And then, of course, the thing that seems to take the longest is linking in all of the communications. So that particular unit has a Wi-Fi connection device. And I'm trying to remember the name of it, but when you go to hook up your Wi-Fi, you can just simply push that button in there and it will search for available Wi-Fi, and then it will handshake and link up. So, you know, link into your next door neighbor's Wi-Fi, what the heck, if you've got the password. Save some money. I think they also have a unit there that you can do if you're in a more remote location where you can hook into cellular service. So that's a little add-on. So how do these things fit in here? Let's move back here. This is the typical system, and they where you would have, this is not such a great picture because they don't have all the components. In fact, let me just skip over that because that's not as good as I would like it to be. So let's take a look at if you decide you want to put in batteries into your system. So how is that going to connect up typically? Well, of course, you're going to have your microinverters attached to each panel on the roof. Then you're going to come into the combiner box. And the combiner box, these will fit in just as we've just been discussing. In any of those 4 branch circuits will come into the combiner box. If you've got a bigger system than that, you're going to need to have multiple combiner boxes. Then it will wirelessly communicate with the smart switch. It will also wirelessly communicate with your battery system. And in that smart switch, you're going to connect your batteries into the smart switch. You're going to physically connect your combiner box into the smart switch. And then you're going to connect, there's a port there if you've got any generators. There's a port there that you'll connect into. And then you can go to your main load panel, or you can go also if you've got critical load panel. And then there's typically also between, they don't have that drawn. I don't know why Enphase leaves it out, between the load panel and the smart switch, you're going to have an AC disconnect. And also between your batteries and that smart switch, you're going to need a DC disconnect. I don't believe that's built into that unit. So let's take a look inside that smart switch, because that's probably something you haven't seen, haven't worked with. This is what it's going to look like inside of there, where you're going to be making all of those connections. So if we look at this diagram, let's go ahead and pull in. Hopefully you'll be able to see where things are connecting. But once again, it's pretty straightforward, pretty plug and play. You're going to come in with I've got mine where it's being blocked here. Let me move that up just a little bit. Whoops. Yeah, so you're going to come in with a connection point here, which is from your AC combiner box. So that's these two terminals in the bottom left-hand corner there. So you're going to have your two hots coming in there. Of course, they're all going to have a neutral that's going to connect to that neutral bus bar. Then you've got a connection here from your batteries. So it comes in with the positive and the negative in the battery there. Or what do you think? With this one, no, I think it comes because it's coming from, it's an AC coupled system. So again, those will be the two hots, because in the Enphase battery system, they actually have microinverters built into that unit. So it's going to be converted from DC to AC there and then exported as AC. So it connects down in there with the connection to the neutral. And then there's a plug to the right of that in case you decide to add a generator in the future. They also have an output for your sensor wires. And there's an output here. That's the sensor wires are what they have listed as I/O. And then if you want to use a critical load panel, there's an output connection there where just above those connection points I was mentioning, where it says the load breaker 200 amp maximum, that's for your critical load panel. And then over to the right above the neutral bus bar are the outputs to your main breaker. And then you've got breakers that will control the combiner box input, which is basically the input from the solar array. There's breakers there for the battery, and then breakers to go to the auto transformer, the transformer switch to turn that off. And really that's kind of it. You know, you'll come into this unit, connect in from your AC disconnect or from your AC combiner box, connect in from your battery, connect out to your main service panel, but of course you'll go through an AC disconnect on your way there. And then if you've got a critical load panel, you'll go from there. And the auto transformer switch is designed to automatically kick off, switch you over to that auxiliary output point should there be a power outage. So hopefully, you know, what are some of the pricing issues? You know, this is, I just looked it up and pulled them at random, but you can see the cost element for these units. There's going to be, the combiner box usually runs somewhere between $600 and $700. The batteries running around the 3,000 mark for each of those 3 kW, 3.3 kW units. And then the smart switch seems to run about $2,000. So one of the things I was thinking, let's see if I can back up to the screen where there was more of an over diagram. It seems to me that really the only pre-advanced planning that is going to be required, typically you're going to put that combiner box outside somewhere near your meter, and you're going to have an AC disconnect that is located there as well. I guess the only advanced planning is going to be to leave space for the smart switch to go out there, because you know, you'll be able to disconnect and connect in there with the wiring. It's not going to be that big of a problem. You're just going to be running from, instead of from the combiner box to the AC disconnect, you'll run from there to the smart switch, and then from the smart switch to your AC disconnect. So as long as you've left space. And then the other unknown is going to be where you're going to put your batteries. And as we've discussed in some of the previous meetings, the new regulations coming through the residential code is that batteries are going to have to be outside. So, you may want to factor that into the design as you're moving forward. So any questions on that? Going to switch us over to gallery view. Oh, you guys are being awfully quiet. Has anybody worked with one of those auto transformer switches?
Yes, I have.
Okay, and did you run into any problems? Anything that we should be aware of?
No, to me, it was a little bit more complicated than solar systems, but after some time with technical support, we did get it to work. Nothing particularly challenging that I go back on it. It's just their commissioning process took much longer than their training videos indicate.
Oh, okay.
So I actually just purchased the IQ4 combiner and the IQ8 pluses, and I've been wrestling with how to surge protect it. Like, do you need to surge protect both? Like, I'm gonna have two 20-amp branch circuits coming in because you can only have 13 panels on a 20-inch branch, and I have 18 panels. So I was wondering how to combine those. Do I need to get two surge protectors and wire those in line before I get to the 20-amp breaker in the combiner box?
I'm trying to think it through. My guess is probably.
That's kind of where I was at. I've been thinking about this for like 2 weeks now, and I can't visualize a way to pick up both circuits and not gain amperage, and still have my 20-amp branch circuits and go through one diode or whatever.
Yeah, you may also want to put surge on the incoming from the utility as well.
And another question I had on that combiner box is I'm doing a ground mount system, and it's going to be about, I don't know, 100 foot from my house. And I was thinking about putting that the combiner box out at the array itself, like up underneath the panels or something like that, and combining them and then taking the 80 amp wire from there to the house to the AC disconnect into my meter. So running that 100 foot, or would it be best to run my two branch circuits through conduit over to the combiner about 100 foot from the ground mount array?
No, I don't see any advantage to running that. I mean, I would think combining them under your array makes sense.
That's kind of what I thought too, but that's where I was with it. But if anybody's got an objection to that, I'd like to hear it.
Well, does anybody see a problem with then? I'm going to mute you when I'm talking because I'm getting some feedback there, and then I'll unmute you afterwards there, John. But does anybody see a problem with then putting the surge protection on the output from that combiner box, say for instance at the AC disconnect, and then avoiding the need for two of the surge protectors coming from the array?
I'm not sure. Are we talking about surge protection or overcurrent protection? I'm not quite sure.
I think he's talking about surge protection because the overcurrent is going to be built into the combiner box in the form of the breakers.
Okay, so surge protection it's an option. I mean, it doesn't have to be built in. So
right, I'm just thinking that you're going to be if you do put in an auto disconnect and you put in a battery bank, that's some serious money that you've just invested, and it would be good to protect it from the surges, and the risk is going to be from both the array and from the grid as far as source of surge. So be nice to protect it on both sides. Yeah, I don't see a reason why you couldn't put your surge protection from the array at your disconnect which I would recommend locating right after your combiner box up at the array. So essentially, if you're coming in with multiple branch circuits on a ground mounted system, you're going to come into the combiner box under the array, leave that combiner box and go to an AC disconnect located under the array where you can put your surge protection, and then run all the way to probably another AC disconnect that's located at the house right next to your meter. The reason I'd recommend 2 of those AC disconnects is you said it's about 100 feet away. It's nice to be able to have a place to disconnect out there at the array in case you're working, out there, or you have a problem, you see wires sparking or something.
No, yeah, my thought was once they lose signal from the grid, there shouldn't be any power coming out of the inverters at that point anyway, right? So if I
Correct.
disconnect the AC, just one AC disconnect at the house, that ought to kill everything.
It should. It should. It's like having multiple. Here, it's like having multiple shutoff valves in your water supply. You want to be able to shut it off at the sink. You want to you have a main shutoff, but you can have multiple shutoffs through the system. So, adding an AC disconnect up there is $100, additional cost, but may prove to be helpful. I mean, obviously you could open up the combiner box and flip the breakers and turn it off that way too. Because
they're rated disconnect. So,
pardon?
The combiner would qualify as a disconnect.
It would, but then of course you're going to still need to have, if you want to put a surge protector on the output. I mean, I guess you could put that at the AC disconnect up there at the house.
Confused. I'm wondering if we're missing something. We've put in probably 50, no, probably closer to 80 systems, and we've never put in a surge protector.
Well, maybe I'm over paranoid, but I mean, I like to put in surge protectors to protect any stray voltage, lightning strike or whatever that might come from the array and follow its way down. The breakers aren't gonna be quick enough to handle that. So a surge protector is only gonna, again, it adds another $80 to the system. But I'm being very cavalier with John's money. I'm happy to throw out an extra $80 here and another $100 for a disconnect. So, I'll just keep spending your money, John. So.
The system, we haven't talked about load control. Does the Enphase system need to have a load controller built in with the battery backup?
I think the load control, of course, the production control is built into those CTs, I think, at least production monitoring. My guess is that you would have to buy a separate add-on for load control. Where you can get them, either get a service panel that has that built in, or they have all of those branch circuit CTs and phone systems. I know there's a lot of aftermarket products. I don't think it's built into the Enphase system, off the shelf.
I know if you do the sunlight backup with the IQ8s, it's basically almost mandatory. They say it's highly recommended, whatever that means. They say it's basically highly recommended to have the Enphase load control built in. So I think they can do up to 420s or 240s branch circuits where they can control a load on and off.
Okay.
But with the Enphase battery, I don't know if it's requested or not. I don't know.
Yeah, what you're hinting at there, because everybody may not be aware, is that the Enphase IQ8s do have that option of acting in a standalone manner without batteries if the sun is shining. So essentially, you're going to get power even if the grid goes down. It'll disconnect, run critical loads, but you're limited to the amount of power that the array is going to generate, and obviously that's going to be variable because of the sunlight. And I know they do have a hierarchy supposedly built in of how they turn on and off those circuits, but it's very crude. It's like it's like a hierarchy of which output circuit will be energized first kind of thing. And if there's not enough power, it just simply shuts it off or doesn't turn it on. So I didn't really research that load control that much.
Yeah, I have one contractor who installs the sunlight backup, and it's probably not 100% legit because Enphase says do not add any loads to the controller, but they actually do. They actually put some very small loads in the controller where they don't use the generator and they don't use the charge the battery. So they have two circuits available, and they put 15 amp breakers in there or something and run some small loads, maybe the refrigerator or so. It's not recommended by Enphase, but it definitely works and is very cost effective. And it runs on sunlight backup only.
Yeah, why wouldn't they recommend it though? That's kind of their whole shtick for selling it.
Well, it has a stick. When you open the controller, it has a sticker in there and say, do not use this for loads.
that
So
reminds
that-
me.
Yeah.
It reminds me of a little, I remember going and buying truss plates that you put trusses together. And there was a sticker on the truss plates that said not to be used on trusses. And I was like, oh, okay.
Yeah.
Well, that's what they're for. So it's probably some lawyer got their hands on it. But
it's a very cost-effective way of doing it. But when we do it, we say we don't really want to have anything to do with it. So
yeah. Well, another thing to worry about too is when you're sizing your battery banks, make sure that your battery bank is sized appropriately for your array, because you don't want to put too small of a battery bank to where you'll overwhelm it from your array when you're in standalone mode. So that's because I was really kind of thinking for my own personal world, it'd be nice to just have a little battery and then I've got some power, and at least it would keep the array going. But you run that risk. Let's say you've got a 10 kW array with a 3 kilowatt hour battery bank, and the grid goes down and it kicks it into standalone mode, and you don't have that many loads being generated. You can overwhelm that battery with the power from the array. So hopefully there's a charge controller or something built into your system that will control that. But if there isn't, and it strikes me that in Enphase, that was an issue. You had to make sure you didn't stick a tiny system onto a bigger array.
Is there a way you can just associate the battery with like one circuit, critical circuit, instead of, so it's, so the rest of it is just going in directly into your load center?
Yeah, I'm sure, there would be, the question is, would it be a better option, I guess, to just deal with load control rather than through hard wiring, just through your load control, so that you have a little more flexibility as to which loads you wanted to allocate to that battery backup. Essentially what you're saying is, can you just simply create a critical load path, from the battery when you're in standalone mode? And yeah, for sure. But you can probably
That way, if your battery's undersized and you don't overwhelm it, that's what I was thinking.
Well, there you'd have to, that would make sense, because especially if you're coming in with multiple branch circuits with an Enphase system, could you set it up where only one branch circuit, for example, is feeding the battery? You're now limiting how much power you can draw, during an off, because the other ones wouldn't be connected. I'd have to look into that more. Usually there's a way to do things, when you start playing those games. Yeah, Bill?
Yeah, I'm a friend of mine is developing a system. I have a 20-foot container that I charge my electric vehicle from. And the lithium battery, as everyone probably knows, is quite expensive. Mm-hmm. And in an effort to get away from expensive lithium batteries, My friend is developing a black box that goes between, that essentially senses the amount of solar power coming in, and with communication from the EVSE to the car, that's the EVSE tells the car how many amps it can supply. So he is modulating, if you will, the signal to the car. Oops, a cloud came over the sun. I have to throttle down the amount of amps / power going to the car. So essentially eliminating the need for an expensive lithium battery. This all plays into the load control discussion we've been having. And I might also add, we're also here at the TXRX Labs in Houston, looking at putting in a greenhouse, solar greenhouse, and solar would drive the fans in the greenhouse. And similarly, you could put a variable frequency drive to control the load of the fans. And I think the VFD would accept a signal from the solar indicating change the speed of the motors, hence the load. So we still also eliminate the need for an expensive battery. Does that make sense?
I figure if you said it, Bill, it probably makes sense. I know, I was just thinking too, we've got a greenhouse at our farm, and they actually have a, I think it's expansion of liquid type venting system. So when the system reaches a certain temperature, the vents open automatically. But that's through I guess, a restriction and expansion of hydraulic fluids within that unit. So I don't know if that's something else to incorporate in. You know, it certainly doesn't run a fan, but it does help with passive venting. All right, well, we're going to run up against the time here. So anybody have any wise last words before we shut off here? No? Okay. All right. Well, we'll see y'all next week. Thanks a lot.